right, these notes are going to cover day 1 of chapter 12. It is stoichiometry using the balanced equation. We're finally looking at what stoichiometry is. It is the study of quantitative relationships between amounts of reactants used and products formed by a chemical reaction. Another way of looking at it, it is the calculation of quantities in chemical reactions. We know that when it comes to coefficients in a balanced equation, they can mean two major things. They can mean particles, right? So I can look at the substance and it may be atoms, right? Formula units or a molecule, or they can represent moles, but they never represent grams. So let's say I'm looking at this reaction. We're going to complete the table using information represented in the chemical equation below. This is definitely balanced. 2H2 plus 1O2 gives us 2H2O. H2 is a molecule, O2 is a molecule, H2O is a molecule. If for some reason this compound over here started with a metal, we would call that formula units. If this was just one capital letter, no 2 after it, they would be atoms. So you would specify based on what is the formula of the reactant or product. So in this case, if I'm looking at hydrogen, the formula is H2. There's 2 molecules. Why are there 2 molecules? Because there's a 2 here. I could also say that there's 2 moles of the hydrogen. For oxygen, it's O2. There's a 1 in front, so it's 1 molecule, 1 mole. Because remember, the coefficients represent the particles and the number of moles. For water, H2O, there's a 2 here, so it'd be 2 molecules and 2 moles. So your table should be filled out. So now we're looking at what this really means. It really means, right, that we can look at particles or moles. But the one that is more useful would be moles. Because remember, we don't count out the particles. We can't even see the particles, but we can quantify the moles. So moles are going to be more important. The mole ratio is a ratio between the number of moles of any 2 substances in a balanced chemical equation. So it has to be balanced, and it can be between 2 reactants, 2 products, reactant product, it doesn't matter. It's the ratio of any 2 substances. So this is why I've been so picky about you labeling, because now we're going to look at one substance and go to a completely different substance. How many conversion factors can be written from this one equation? All right. So if I first look at 2 moles of H2 equals 1 mole of O2, I can write it as 2 moles of H2 over 1 mole of O2. Or I can write, right, the inverse, 1 mole of O2 over 2 moles of H2. Now, something that I'm very picky about. A mole ratio has to have the unit mole in the numerator and the denominator. You can't just write 2H2 over 1O2. You will not get credit on the homework, the lab, the test, the review, so make sure that you are including mole in the numerator and denominator. For the next one, same idea. 2 moles of H2 over 2 moles of H2O, or I can write it as the inverse, 2 moles of H2O over 2 moles of H2. Now, if you want to reduce these 2's, you can, but not until you're doing the work for dimensional analysis. Leave the mole ratio the way that it's supposed to be until you are doing the actual math of the problem at the very end. So our last one would be 1 mole of O2 equals 2 moles of H2O. Once again, all mole ratios have to have the mole unit in the numerator and the denominator. So this would be 1 mole of O2 over 2 moles of H2O, or the inverse, 2 moles of H2O over 1 mole of O2. So now we're going to use the mole ratio to figure out different amounts of reactants or products. So here's our stoichiometry island diagram. In chapter 10, we learned how to go from mass to moles, moles to particles, particles to atoms. Now what we're going to do is learn that we can go from one substance to a completely different substance using the coefficients from the balanced chemical equation. Keyword, balanced. It has to be balanced. So that's why you're practicing with balancing equations for chapter 12. So let's look at this first problem. How many moles of O2 are needed to react with 6.4 moles of H2? All right, so I start with my given, which is 6.4 moles of H2. And I'm trying to find moles of O2. So remember, in dimensional analysis, you start with your given, set up your workspace, write the unit and the substance that you're trying to find. I'm already in moles, so now I want to put moles of H2 down here. And what I want on top is moles of O2. When I'm going from 1 mole of a substance to a completely different substance, I have to use the coefficients, 1 O2, 2 moles of H2 from the balanced equation. So the 2 goes there, the 1 goes up there. Now for your homework, I would like for you to either circle or put a heart around your mole ratio. All right? So you have to identify that it's your mole ratio. You can circle it or put a heart around it, but please make sure you identify that you're using that mole ratio. So then now I just do the work. These here are unlimited sig figs. The 1 and the 2 are unlimited because those are coefficients. So I have 2 sig figs here. I need 2 sig figs at the end. 6.4 divided by 2 is 3.2 moles of O2. Now we move on to 2. How many moles of H2O are produced from 6.4 moles of H2? 6.4 moles of H2 is my given. Set up my workspace. In the end, I want to find moles of H2O. So I want moles of H2 to cancel, so I put that there. Moles of H2O up here. Notice that this is a reactant, this is a product, it doesn't matter. When I have the mole to mole ratio, I'm going to use the coefficients in the balanced equation, right? Circle it or put a heart around it, right? And then I do the work now. If you notice, right, that 2 and 2 cancel, right, the answer is just going to be 6.4 moles of H2O. All right, so now we're looking at number 3. How many moles of KClO3 must decompose in order to produce 9.0 moles of oxygen gas? All right, this problem cannot be done until you balance the equation. So first thing you want to do is balance the equation. In fact, if you're doing stoichiometry and your mole to mole ratio is 1:1, you should always double check that you did balance the equation so that you're not getting the wrong answer. So to balance this, we're going to put a 2 in front of KClO3, 2 in front of KCl, 3 in front of O2. Now I write my given 9.0 moles of O2, and I'm trying to find moles of KClO3. Mole of O2 go down here, mole of KClO3 up here. When it's a mole to mole ratio of 2 completely different substances, I use the coefficients in the balanced equation. So 3 goes here, and the 2 goes here. Now I multiply everything on top, divide by the bottom. 9.0 times 2 divided by 3 is, all right, here 2 sig figs, 2 and 3 here unlimited. So the answer is 6.0 moles of KClO3. Don't forget to put a circle around the mole ratio, or you can put a heart. It's up to you. But I want you to identify that you have used the mole ratio. So that's it for notes. So your homework, you've already done this first page, front and back. Now you'll have to complete this page, the third one, right? So page 2 front, so 26 to 40. This entire thing is due Wednesday, has to be uploaded in Google Classroom. And your other homework is due 12-1, front and back. Don't forget to balance on the back. Mole ratios have to have the word mole in the numerator and the denominator. Here the mole is hole punched, but make sure that they have mole in the numerator, or make sure you have mole in the numerator and denominator.